My name is Dale Loberger, and this video is based on a presentation that I did for the 2014 Brigade of the American Revolution School of Instruction for Surveying and Engineering. It's part of a whole series of presentations that I would like to do on colonial surveying. This time I'm specifically looking at the tasks of the chainmen, according to Samuel Wyld from his book, The Practical Surveyor, first published in 1725. This was a book that was commonly referred to, along with a couple of others, in early America, because Samuel Wyld did practice in North America, particularly the southern part of North America, as well as the Caribbean. The chainmen had a very specific duty. Their job was to measure linear distances. And this is separate from what the surveyor did in actually measuring the angle between specific points. The chainmen worked typically in pairs, not directly supervised by the surveyor as we think of today. When we look at modern surveyors in a total station, the person at the far end is being directed by the person at the total station. And I think that's where we get a lot of the interpretation today. But in the 18th century, surveying was actually practiced a little bit differently. The chainmen would have been at least in pairs. There could have been even four, someone else holding the rods. But minimally, there was two, and I think that was probably fairly common. And I say that based not only from these Swedish drawings of chainmen, but also from this chainman's oath that we see that's circa 1740. And it reads, so this is something that would be carried and administered to chainmen because they're not skilled professionals, but people who would be taught the craft very quickly. And here's an oath that would be administered, and it says very simply, U, AB in place of the first person's name, and CD, another name, because they're quite often in pairs. Being desired to assist, and there'd be the name of the surveyor here, surveyor, in carrying the chain, do swear by the ever-living God that you will faithfully assist the said surveyor in his service, and that you will keep a true account of all lines and measures by you taken, and the same give up to the said surveyor at his desire according to your best skill and ability, so help you God. What this tells me is that the chainmen are not working directly under the surveyor, but they are doing their work, and when the surveyor asks for their measures, they need to give that up to the surveyor. So now the question becomes, what is the process that they went through? So I've diagrammed out here how this works, and this is according, again, to Samuel Wyld's book. It was known very commonly that the corners of property were trees. These were considered permanent markers, at least permanent in the sense that as long as that tree is there. And that's quite often how surveyors looked at them, as these are these permanent sort of objects. So starting at a particular tree, we see a chainman here holding a staff, and he would look forward to the next tree, which is going to designate the next permanent marker, or the next corner for the property that we're looking at. So if we back up to the first chainman, he's beginning at his starting point, and a second chainman will come along and drag the chain out to its full length. Now a typical chain, at least that determined by Mr. Gunter, would be 66 feet. And there's lots of reasons for the 66-foot chain as opposed to an engineer's chain, which would be 100 feet. Because as we're measuring areas, we're interested in acres. And 10 square chains equals 1 acre, as opposed to measuring things in feet. So if we used an engineer's chain of 100 feet, then we would be measuring in feet. We take the total area and have to divide by 43,560, as opposed to simply moving the decimal over 1, since it's 10 square chains to an acre. Also very common was the half Gunter's chain at 33 feet, or 2 poles in length. The only difference there is that we need to remember that the total number of chain lengths that we are counting needs to be divided in half when they're reported to the surveyor so that we're measuring in full chains as opposed to half chains. But as Wyld describes, the underbrush was so thick in the southern American colonies that we typically couldn't see 66 feet or be able to pull the chain conveniently 66 feet into the woods. And so the half chain was favored in that case. My diagram, I'm going to simplify that. There's not a lot of trees in the way. We're going to use a 66-foot chain. So the front chainman steps out to the end of that first 66 feet. He is wearing around his shoulder a quiver of wooden arrows. These are just sticks to be placed into the ground. Now Wyld makes it very apparent that he counts 9 arrows in that front chainman's quiver. There's again debate of some modern reenactors that we need 10 or even 11 arrows, but I want to show you how using Samuel Wyld's description we can actually use 9 arrows and make it work very, very conveniently. It makes lots of good sense. That's not to say that there weren't some who carried 10 arrows, but the point where you switch the arrows is different, and how many arrows you switch at that time would be different. But carrying 9 arrows makes a lot of sense to me because I use Samuel Wyld's method in all that I do. So in this case, again, the surveyor, the front chainman has gone to the end of the first chain, pulls it tight, and he sets his staff at the end of that chain. And he'll step to the side so that the rear chainman can look over the top of his pole. Again, Samuel Wyld describes these poles as typically being 5 foot tall. That puts it right at about eye level. So it's very convenient to look across the top of your staff and look across the top of the staff at the other end of the chain and still be able to see the tree, the next corner beyond, so you can see whether or not you're in a straight line. Once the rear chainman has determined that the front chainman is in a straight line with that next corner, he can let the front chainman know that it's okay to take his pole out and replace it with one of the arrows from his quiver. So that's at the end of the first chain. We now have 1 arrow in the ground, and the front chainman will move forward with 8 arrows in his quiver. As the rear chainman approaches that arrow that's in the ground, he will immediately pick it up and replace the hole in the ground with his staff and hold the end of the chain with his staff there. The front chainman again will pull the chain taut to the end of that. He will place his staff, and the rear chainman will again look over the top of his staff and to the staff of the front chainman to the tree that marks the next corner so that we can see if it's in straight alignment or not. And as a check to make sure that we continue that process correctly, after the rear chainman has decided that the front chainman is in line, the front chainman will then backsight by looking back over the rear chainman's staff to see if he can see the previous corner in a straight line. This is a way of confirming, of checks and balances to make sure that we're heading in the right direction. Once everyone agrees that we are at the end of that second chain, the front chainman will take another arrow from his quiver, place it in the ground in place of his staff, and the chainman will move forward again. As the rear chainman reaches the end of that second chain, he will pick up that second arrow, placing it in his quiver, and replace the hole in the ground with his staff. And he'll sight forward, repeating the process again. The front chainman will then look back to back sight and ensure that they are continuing in a straight line. So this will ensure that this process continues each chain along the way. So we have now measured 3 complete chains. The chain has been stretched a 4th distance, but it has not measured 4 yet until the front sighting and the rear sighting is done to make sure that it's okay to place the next arrow. So now as the rear chainman moves forward again, we're at the end of 4 chains. This process will continue of foresighting and backsighting. We continue the process, 6 chains, Here we're at the end of the 7th chain. We are now at 8 chains measured. The chain has been pulled a 9th chain, and we're again sighting it so that we can both see and confirm that it is at the right distance. And the front chainman's last arrow, the 9th arrow, will be placed in the ground. As the rear chainman moves forward, they have now finished the measure of 9 full chains. They'll continue the process of sighting forward and again sighting backward to make sure that that 10th chain is now measured. But the front chainman does not have an arrow to place in the ground. So at that point, he is out. An out is an actual measure. It means 10 chains. And the fact that he is out of arrows in his quiver. And this is at the end of that 10th chain, no arrows. So at this point, at the end of an out, the rear chainman will come forward and actually meet the front chainman, passing all 9 of his arrows, because they have measured 9 full chains, and then he will replace his staff with the staff of the front chainman, so that they are now at the end of that 10th chain, or the first out. And the front chainman has 9 arrows. So now as they move forward again, the rear chainman is standing at the end of the out, the 10th chain. The chain has been pulled an 11th length. The front chainman has 9 arrows, the same as he did at the end of the first chain in the measure. So we forward sight, the front chainman will back sight. Once it's agreed, he places another arrow in the ground. So that is going to be 11 chains. Now in this case, we don't have another full chain to go. So the front chainman will only go up to that next corner, the tree that will mark that. And he will back sight to the rear chainman, who's not actually at the arrow yet, so he's just along the line. So he'll have done his best to walk along that line. The rear chainman will ensure, the front chainman will ensure that the rear chainman is in line. And once it is confirmed, then the rear chainman will come forward, pull up that 11th arrow, replacing it with his staff. So now we have gone 11 chains, or what we could consider 1 out plus 1 chain. And then he would be looking at how many links, measuring that. Now the chain, when we look at how it is made up of 100 links. Each 10 links has a metal teller on it. Those tellers tell us how many links we are down the chain. So at the first teller, it'll be shaped like a single finger or a single point, and that is 10 links. The next teller will be shaped as 2 fingers or carved out as 2 points to tell us that we're at 20. And then 3 for 30, 4 for 40. And once we get to 50, that's half of the chain of a full chain. So at that point, we'll find a round teller. Round tellers always mean that we're at the middle of the chain. From that point, we'll move on to what would be 60 down the line, but we actually find a 4-fingered teller at that point, and then it goes to 3, 2, and 1. And that's because chains can be measured from either end. So it's measured 10, 20, 30, 40, 50, and then back down again. So in this case, we haven't gone halfway down the chain. So we know that the distance from where the arrow was picked up, from where the rear staff is now, to the next corner is over half of a chain. So we can either measure how many links we have passed, which would be 34 in this case. So we'd have passed the 3 teller and we'd be 4 links past that. Or we could be looking forward and see the round link and then see the 4 link, which would actually be 60, and then if we count from there, we'd be 6 more down, or 66 links from the end. So either we can measure from the end that we're at, which would be 34, subtract from 100 to get 66, or counting the links ahead of us, using the tellers to get down to that 66 links. So the full measure in this case is 1 out plus 1 chain plus 66 links. Since 1 out is 10 chains, we can simplify that to say that it is 11 chains and 66 links. Because there are 100 links in a chain, we can also look at that as being 1,166 links. So you see here, we can actually do unit conversion by simply moving the decimal point. So we could go back to the beginning and say that it is 1.166 outs, because the decimals work out. Or it's 11.66 chains, or 1,166 links. Now you also will find a lot of surveyors, particularly a little bit later, who will measure in poles. So poles is a shorter distance. It's actually 16.5 feet, and we get that number because it is 1/4 of a full chain. So if we have 1 out we've measured, that actually would equal 40 poles, plus 1 chain, which is 4 poles, so that would give us 44 poles to this point. And then we're just over half of another chain, which would be an additional 2 poles to get us the 46 poles. We're a little bit longer than that, so it's actually 16 links short, but 16 links is less than half of a pole, and so the measure would actually be 46 poles. We're not measuring any closer than that. You have to think back again at the cost of land at this time was very, very cheap, and so the need to be measuring down to what we would consider today the foot or the inch level was simply not necessary. So measuring to the nearest link was also not very common. We quite often measured to the nearest 10 links, and in some cases even to the nearest chain. Again, that's going to be a very coarse linear measure, but given land prices and the size of land that we're measuring, it would not be a significant error, especially when we consider how we measure the angles, which would be the subject of another video. Thank you very much for watching this video, and I hope you learned something. Feel free to add comments below.